Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Today's topic for the lecture is the conditions for the formation of ionic bond. So we are having four sets of conditions for the formation of ionic bond. Let's talk about the very first condition. For the formation of ionic bond, for the formation of ionic bond, comma, the one of the combining element must be metal and other must be non-metal, and other must be non-metal. Ionic bond always forms between the metal and a non-metal. Why so? Let's discuss about it. Metals. What are metals? The elements that have tendency to lose electrons are called metals. Whereas, what are the non-metals? The elements that have tendency to gain electrons. The elements that have tendency to gain electrons. Now, the electron that have been lost by the metal is gained by the non-metal. Now, the elements which have tendency to lose electron becomes cations after the loss of electrons. What are the cations? The elements bearing positive charge are called cations, and they have been formed by the loss of electrons. That is, cations are always formed by the metals. And on the other hand, that elements that have tendency to gain electrons become anions after gaining electrons. So anions are always found by the non-metals. Now, the elements which have one, two, or three valence electrons readily forms cations. The element having one valence electrons belongs to the group number 1 of the periodic table. The element having two valence electrons belongs to the group number 2 of the periodic table, and the element having three valence electron belongs to the group number 13 of the periodic table. The group number 1 elements. What are the group number 1 elements? It's lithium, sodium, potassium, rubidium, cesium, francium. The group number 1 elements readily lose their one valence electron and acquires the oxidation state of +1 by losing their one valence electrons. That's group number 1. Now let's talk about the group number 2. Who are the members of group number 2? It's beryllium, magnesium, calcium, strontium, barium, and the radium. These elements readily lose 2 electrons to acquire an oxidation state of 2 electrons, that is plus 2. Now let's talk about the group number 13. It's boron, aluminium, gallium, indium, and the thallium. This group readily loses 3 electrons to acquire an oxidation state of plus 3. So that's all about the cations, that is the elements which have 1 or 2 or 3 valence electrons readily form cations. The elements which have 1 valence electron belongs to the group number 1 and have an oxidation state of plus 1. The element having 2 valence electron belongs to the group number 2 and have an oxidation state of plus 2. The elements having 3 valence electron will belong to the group number 13 and have the oxidation state of plus 3. Now let's talk about the anions. The elements which have 5 or 6 or 7 valence electrons will form anions very readily. The elements having 5 valence electron will belong to the group number 15, that's nitrogen, phosphorus, arsenic, antimony, and the bismuth. The group number 15 elements readily gains 3 electrons to have their octet completed. That means they are having 5 valence electron, it's short of 3 electrons, so they will gain 3 electrons to have 8 electrons in their valence shell. So their oxidation state will be minus 3. Now let's talk about the elements having 6 valence electrons. The elements having 6 valence electron will belong to the group number 16, that's oxygen, sulfur, selenium, tellurium, polonium. So these elements are short of 2 electrons to have 8 electrons in the valence shell. As they are having 6 electrons in the valence shell, they will acquire 2 electrons to have their octet completed, so they will have the oxidation state of minus 2. And on the other hand, let's talk about the elements having 7 valence electron will belong to the group number 17, that's of halogens, is fluorine, chlorine, bromine, iodine, and the astatine. Now these elements are short of only 1 electron to have 8 electrons in their outermost shell, that is to have octet. As they are having 7 electrons in their valence shell, so they will acquire 1 electron and will have an oxidation state of only minus 1. So these are the groups of elements. The group number 1, 2 and 3 will form cations very readily, and on the other hand the elements of group number 15, 16 and 17 will form anions very readily. After that there will be the electrostatic forces of attractions between the cation and anion, and there will be the formation of large macromolecule called ionic compound. So now let's talk about the second point, energies. Now let's talk about the energies. Now cations, let's talk about the cations. The elements which have low ionization energy The elements which have low ionization energy will form cation very readily. That's a point in terms of energies. First of all, what is ionization energy? It is the energy required by an element to lose an electron. So if ionization energy is low, that means that element have very high tendency to lose electrons. That means it is losing electrons at a very low energy. So that's why they will form the cation very readily. So the elements of group number 1, 2 and 3 have a very low ionization energy, which favors the formation of cation. So low ionization energy favors the formation of cation. Now let's talk about the anions. The elements which have high electron gain enthalpy, electron gain enthalpy will form anion very readily. So what is electron gain enthalpy? It is the energy released when an element gains an electron. So if the element has a high electron gain enthalpy, that means it has a very high tendency to gain electron and to form anion very readily. So a high electron gain enthalpy will favor the formation of anion. So sorry, a very high electron gain enthalpy will favor the formation of anion. So we have talked about the formation of cation and the formation of anion in terms of their energies, in terms of the ionization energy and in terms of the electron gain enthalpy. After that, the third condition is electronegativity difference. Electronegativity difference. The very high electronegativity difference, the very high electronegativity difference will favor difference between the combining elements. Combining elements will favor the formation of ionic bond. Now, as we all know, the ionic bond is always formed between metals and non-metals. What is electronegativity? It is a tendency of an element to attract the shared pair of electrons towards itself, which depends upon the effective nuclear charge. So in case of metal, the electronegativity is very low. I am writing low electronegativity. But in case of non-metals, it's high electronegativity. Because it has a tendency to gain electrons there, it has a very high effective nuclear charge, that's why it's a gaining electron. So non-metals will also have the high electronegativity due to this. So there's a huge electronegativity difference between the metals and the non-metals, which favors the formation of ionic bond. Now the very last condition, energy associated with the whole process. I'm writing energy associated with whole process, with whole process of formation of ionic bond. Now let's talk about the first of all, let's take an example of NaCl. As we all know, so sodium, it will lose one electron, minus electron, and will form the Na positive ion. Here the energy consumed, I am writing the energy consumed, the energy consumed is ionization energy, is ionization energy. Now let's talk about the chloride or a chlorine. Chlorine will readily gain electron. Its whole electronic configuration is given in the previous lecture video. Please do have a look of previous lecture video to understand this point. As a chlorine, it will readily gain electron to form the Cl negative, the chloride ion. As it's a gain of electron, so it's the electron gain enthalpy and is always liberated. Here I'm writing energy liberated or evolved is electron gain enthalpy. Now after that, what will happen? After that, Na positive and Cl negative will arrange, first of all they will have an formation of ionic bond between them. After that, I'm writing 1 mole of Na positive ions and 1 mole of Cl negative ions will arrange themselves, will arrange themselves in alternate fashion in 3 dimensions through ionic bond formation. This process is the called formation of lattice, is called formation of lattice. So the energies also evolved during the formation of lattice or 1 mole of lattice. So I am writing here the energy is liberated or evolved during the formation of lattice. Now let's talk about whole energies which have been consumed or which have been liberated. So I'm writing here, I'm writing energy consumed, and here is energy liberated. The energy consumed is ionization energy. The energy liberated is electron gain enthalpy plus lattice energy. So here overall magnitude of energy liberated is greater than the magnitude of the energy consumed which favors the formation of ionic bond. So I'm writing the magnitude of energy liberated, the magnitude of energy liberated is greater than magnitude of energy consumed, which favors the formation of ionic bond, which favors the formation of ionic bond. So these were the conditions which favors the formation of ionic bond. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.